Good day, guys. Once again, welcome to our class, Calculus 2, and our topic for today is trigonometric functions. So here, in front of you could see 6 different trigonometric formulas. So the first one is sine, integral of sine u will be equal to negative cosine u. Cosine u, integral of cosine u is equivalent to positive sine u. Tangent u will be equal to negative ln cosine u plus c. And integral of cotangent u will be equal to ln sine u plus c. And in your integral second u, that will be positive ln second u plus tangent u plus c. On the last one, that is cosecant u du, that will be equal to negative ln cosecant u plus cotangent u plus c. So here we have trigonometric identities, if you could recall this one in your past mathematics. So tangent u is equal to sine u over cosine u. And your sine u will be equal to 1 over cosecant u. And cosine u is 1 over secant u. While your tangent u will be 1 over cotangent u. Obviously, your cotangent u will be equal to tan u. Just transposing this one, same what happened to your secant u, the same here, and your cosecant u. So let's try first. If you know that tangent u is equal to negative ln cosecant u, that's proof in the trigonometric identities, tangent u is equal to sine u over cosine u, di ba? It tells here that these two are equal. So what if we put both integrals on the two? Will they have the same answer? Let's try. Okay. So tangent u, we know that this is equal to negative ln cosecant cosine u. So here we'll have our u. Okay. Our u will be cosine u because we'll be trying here. The answer is logarithmic. So we'll try to get the denominator as our u, and we will derive this one so that if the denominator is the differential of if the numerator is differential of the denominator, then you will use trigonometric function, logarithmic function with all those trigonometrics. So du, so we're still proving this two. What is the derivative of cosine u? Derivative of cosine u is negative sine u, right? So you always remember, if you have integral of sine du, the opposite of that is, if the answer is negative cosine, if you derive this one, that will be positive. While on the cosine, if the integral of cosine is positive, is sine u, therefore the differential of your cosine u is negative sine u. So okay, we will use here, because this is already, we'll try x. Okay, so du. Then I need to get your du, this one, so that it makes it easier. Sine u. Okay, so now we'll just substitute it there. Okay, and so we have integral, we have sine u. What is our du? That is dx over negative sine u all over. So let me stretch your integral sign, and denominator is cosine u, which is our x. Now, if you could see, we could cancel the sign here and this one, but the negative will be put outside, right? Negative. What remains will be dx over x. And we know on the past topic with logarithmic function that dx over x, that is ln of x plus c, where our x x is equal to cosine. So we have cosine u, sorry, that is u, cosine u plus c. If you could see here, the answer for your tangent u is at negative ln cosine u plus c. Here, the integral of sine u over cosine u is still the same, ln cosine u plus c. Therefore, the two are the same. So now let's try another example. So now we'll focus on trigonometric functions. So if your given will be like this, where your sine, it has not just x, so you have 4 on your x. Because here, diba, we'd say that sine u will automatically be equal negative cosine u. But here, your u is the x, but this one don't have 4. Therefore, you need to first let that value and derive that value. Okay? So your du, derivative of 4x is 4 dx. So therefore, your dx will be equal to du over 4. Okay? So you could do the other means if you could see in the book. Me doing this, so it's just simple. It's just a plain substitution, algebraic substitution. So that you are clear where you get those values outside the integral sign that the others, some of my students ask, sir, why it becomes like this? So you tell, in order to balance this and that, you need to put here and there. So for that to be answered clearly, that's why I get the value of the dx. So now, you need to substitute this one to the given. So you will have sine, what is 4x? That is our u. And what is our dx? That is our du over 4. Then, we now move the constant value outside the integral sign. So therefore, you will have, 1 over 4 outside the integral sign, sine u du. Then if you could see, sine u du is just exactly equal to the first trigonometric formula. Now, this form and this form is already the same. So therefore, we could say that the integral of sine u will be equal to negative cosine u plus c. Or you will have negative 1 over 4 cosine u plus c. But again, we are not yet finished because our given are all on x. Therefore, we need to substitute back the value of your u, which is equal to 4x. So you have negative 1 over 4 cosine 4x plus c. Okay? So, check first. So, look at it first. Okay? Question? Let's have another example, more example. So let me erase first this one. So you could still look with the identities and formulas. Sorry, I only have a small whiteboard, but it could do. Huh? Erase this one. Okay. So let's have another example, which is another example. Let's say let's have integral of 1 plus sine 2x. Okay, combinations over cosine 2x. Cosine 2x dx. Okay, so think, how can we solve this equation? How can we solve this equation? So we'll solve this equation. So let's try first to separate 1 and the sine 2x with the same denominator. So let's say we have integral of 1, sorry, 1 over cosine 2x plus sine 2x over cosine 2x dx. Okay? So, what will we do next? What will we do next? So, in this case, 1 over cosine 2x, we have 1 over cosine, that is equal to secant u. So, if this is our u, that will be equal, so therefore, this is just equal to secant 2x plus, what is this? Sine 2x over cosine 2x. That is sine u over cosine u, which is equal to tangent. You have 2x, so therefore that is 2x dx. Okay? Then we could integrate it separately. Okay? Okay, integrate it separately. So I think it's already clear. We have there what is for secant and for tangent. But we need first, again, this is not u, this is not one variable, you have value beside your variable. So therefore, you need to have, like what we do in the last example, we let that value as 2x and derive that one becomes 2 dx. And your dx be equal to du over 2. And for the other one, so that di ta kayo ma-confuse, you could still use u. I tend to use sub 1. You have 2x, although they are still the same, du sub 1 equals 2 dx sub 1. Then you have dx sub 1 is equal to du sub 1 over 2. Okay? So, we need to substitute it to your given. Okay? So, we have integral. Okay, separate first. Second, your 2x here is u dx plus integral tangent u 1 dx sub 1. So, ano naman na? So we have integral of secant u dx, that is secant u dx, that is ln secant u plus tangent u plus, for this you have negative, right? So we have negative ln cosine u plus c, cosine u 1. Okay? Okay, we forgot something. Sorry. Okay, we forgot something here. So we forgot to substitute your dx. So let's substitute first our dx. Okay. So second u, then what is your dx here? That is du over 2 plus integral of tangent u sub 1. What is your dx? That is du sub 1 over 2. So we need to move the constant values outside the integral sign. So therefore, you will have 1/2 integral of second u du plus 1/2 integral of tangent u du. Then we will have 1/2. Let me write it in smaller. Second, that is ln second u plus tangent u plus 1/2. That is minus, right? Because tangent u is negative. So let's have 1/2 ln cosine u plus c. Okay? So let's continue. So we will substitute the values of your u. Plainly, we will have this answer. 1/2 ln second. What is our u here? 2x plus tangent, still 2x plus, minus. So we have minus 1/2 ln cosine. Your u here is u sub 1 is, that is 2x plus c. So you could have this answer, or you could multiply it by 2 so that the 1/2 will be eliminated. So you have multiply it by 2, then you will result with ln. So when you multiply it by 2, ln second 2x plus tangent 2x minus ln cosine 2x plus 2c. Or because we multiply it by 2, okay, c becomes c sub 1 2c. So you will have ln second 2x plus tangent 2x minus ln cosine 2x plus 6. You can have either of those. Okay.